Okay, now members, we are going to see how we handle this question. Looks funny, but it's a bit, let us go through it. A particle is projected from a point O on a horizontal ground, moves freely under gravity and hits the ground at A. So it's from here and it's a ground at A. Taking O as the origin, the equation of trajectory of the particle is given by this, where X and Y are measured in meters per second, meters. Find the initial speed and the angle of projection. Now, as you remember, when we had this our theta as the initial there, remember we said we derived these two equations here. Now, here they are giving us an equation, they're telling us that our y from the equation 60y is equal to 20 root 3x then minus x squared. Can you make y the subject? So our y will be 20 over 60 root 3x minus x squared over 60. You can every start from there. Our y is equal to root 3 over 3x minus x squared over 60. Now, you see, in my equation here, in this one there's no x. How can I introduce in x? You see that this one is having x. So using these two, I'm going to make t the subject because here there's no t. So if I make t the subject here and substitute in this equation, let me see. So if my x is equal to u t cos theta, so you can every see that my t is going to be, we are going to get now x over u cos theta. And now from there, let me use this one from my y equal to u t sine theta minus a half t squared. And then substitute in, so you're going to be having u, then x over u cos theta sine theta, then minus a half b into x over u cos theta, the whole square. Let's simplify and see. So this one is going to go with this. So my y here is going to be x sine theta over cos theta, then minus a half. This is going to be x squared over u squared, and the square is on the net cos squared theta. And note that 1 over cos squared theta is the same as sec squared theta from trig. So is that here my y, you see this one is going to give me x, a tan theta, then minus a half g x squared into now, this is going to be sec squared theta over u squared. But what is my sec squared? My sec squared is the same as 1 plus tan squared theta. So I might just do that so that I can easily compare well. Okay, so from there, you can help me see that my y, if I'm write it here, my y equal to x tan theta, then minus, this is going to be g into 1 plus tan squared theta x squared, the whole over sum divided into 2u squared. So now I can help me compare with this one. Now if we compare with y equal to 2, this is the same as x root 3 over 3 minus x squared over 60. And so if I compare, can every see my tan theta is going to be root 3 over 3. And then if I compare this negative, that negative, then you see that this one, I'm going to be adding g into 1 plus tan squared theta, the whole over 2 u squared equal to 1 over 60. The coefficient there is 1/60. So this is negative and this is negative. So we start by getting the initial speed and the angle projection. From here, you can get the angle projection. Our theta is going to be tan inverse of √3/3. And so this is a special angle, which is 30 degrees. So our theta is 30 degrees. Now, they want us to get the initial speed. This one is one which is having our initial speed. So our g, they told us to take our g as 10. So I'm going to be adding 10 into 1 plus my tan here, which is √3/3 squared, then times 2u squared equaling 1/60. Okay, so what am I going to do there? You see, by this one, by this 5, so I have now, this is going to be 3/9. When you simplify this, we're going to be adding, take this 5 this side. I'm going to be adding, okay, this u squared. So my u squared will be, now this 60 times 5 into 1 plus. When you square this, you get 3. When you square 3, you get 9. Okay, so my u squared is going to be, this is going to be 300 into, this one is going to give us a third plus this, which I'm getting 4/3. So multiply there, that our u squared is going to be, is it 400? 400, and our u is going to be 10 meters per second. As simple as that. So from there, now what are they asking us to get? The distance OA. Distance OA. Part B. Distance OA. Now, to get this distance OA, it means that now this particle has moved it up to here. So this point P now is going to be here. Our P is going to be x, y. So meaning, by the time this particle reaches this point, it means that the displacement of this particle is going to be 0. So at A, comma, our y is going to be 0. What happens if our y is 0? Come back, substitute it there. So from my y equaling 2x√3/3 minus x squared over 60. So now I have 0 equaling 2x√3/3 minus x squared over 60. Multiply through by what? You can multiply through by 60. So this will be 0 equaling 220x√3 minus x squared, which I can empty see. At there x is common. I factorize out x. Here I will remain with x, then minus. Or when I take everything the other side. When I take everything the other side, okay, let me not skip that step because people will get lost. What I'm saying, I was taking everything to one side, which is, I wanted to make this positive. So when you take this side, it will be adding x squared minus 20x√3 equaling 0. Start with you to move x. We have this x. I think it's that our x is going to be our horizontal. This x is going to be the horizontal, which we are looking for here. So our x is going to be x minus 20√3 equaling 0. So either our x is 0 or our x is going to be 20√3 meters or 0. Now, for x to be 0, it means that our particle is here at the origin. Then for it to come here, it means that x is going to be this. Therefore, our ON is going to be equaling to x equaling to 20√3 meters, and that will be the solution. Why am I taking it? Because we said at this point, this is where we are going to be having this x. So our x to be here, it can't be 0. Because at this point, it has moved already. The displacement is 0, but the distance is not 0. As simple as that. But here is that the y, this y component, it has moved it from here, then it has come back to 0. So that's why we are taking it to be 0. in this order there. So that's how we handle that, members. I wish you well.